Okay, it looks like we have some technical difficulties, some technical issues. Craig is going to finish up his privilege escalation demos on our next podcast. So I will just start my demo. So today, what I will be covering is a very popular lateral movement technique using SMB named pipes. So if you're familiar with some of the more powerful red teaming tools, they have this functionality of being able to use SMB pipes to do lateral movement and to sort of communicate with other targets. So the reason I wanted to do a demo on this is because I believe a lot of pen testers and red teamers, they will use that capability in the tool, but I don't think they have a really good understanding of how it actually works, myself included. And that's why I was motivated to sort of look into this. So I was curious to know if Metasploit, a very popular pen testing tool, had this capability of using SMB name pipes. And it turns out that it does. So I sort of explored it and played around with it and got it to work. And that's what I will be demoing today. So to start off with, let me talk about the network topology that we have here with my virtual machines. So the first VM is this Kali Linux VM. That is going to be the red teaming box. That's going to be where I'll be launching the different red teaming plays and getting callbacks to my interpreter session. So there's the red box. And the first hop is this VM right here, the Windows boss VM. And this is directly connected. Oh man, I'm getting issues with my screen share here. So okay, cool, that works. So this is the boss one, and it's directly connected to the Kali VM. This is where we're gonna get our first foothold into the target network, is on this boss VM. And connected to the boss VM is this final VM, the victim PC. So this is our final ultimate target. But in order to get here, we need to compromise our first hop machine, the boss VM, and then use it as a pivot to finally talk to this last VM, the victim PC. So let's start. So for those who are not familiar with Kali, with Metasploit, I will talk a little bit about sort of how it works and some of this functionality, so it will become familiar for those who are new to Metasploit. So I already ran some commands here. So what I ended up doing was I ended up setting a multi-handler. So what this is it's a callback listener, so that when we run our payloads on the victim machines, it's gonna be able to catch it, and then we'll be able to talk to our payloads that are executing on the target VMs. So in this case, I have a reverse TCP interpreter, a listener, and it's going to be listening on port 443. And just to show you that this is just a clean environment, right? There are currently no established connections, only my listener here, right? So to kick it off, I will now go to that first hop target VM, the boss VM. So just to show you its name here, so net users, right? So the name of this PC is boss PC. And what's something else I want to show here? Okay, I'll get to that in a moment. But so for this scenario, the red team somehow already got the payload here, and the payload here is shell.exe. It's just an interpreter payload that's going to call back on port 443. And there are a lot of different ways of getting it here. I really like the methods that Craig demoed. He used a Python web listener on his Kali box, and then he used a cert util to grab it. So you can do something very similar to get your shell.exe here. So let's run that, right? So show.exe, we run it, and if we jump back to our Kali box here, you'll see that we have a interpreter session open, right? So that's good. So let's go session list, that shows it where it is, and then we can interact it with sessions and then the identifier for this interpreter session. So we connect. And so for those who are new to Metasploit, notice, so originally for my prompt, I had this MSF exploit. That means I'm still within the context of one of these modules, in this case, a multi-handler module of Metasploit. But when I ran this command session, my prompt changed to interpreter. So now I'm actually interacting with that payload that's running on the target machine, right? So I'm now have a completely different set of commands because now I'm in a completely different context. So if I run get UID, I see the name, the user who ran my payload, and also the name of the PC. So in this case, it's boss PC. And so now what we're interested in doing is we're going to get an SMB listener running on that boss PC, so that when we get to the final target's payload will be able to connect to this middle one, this boss PC, which will ultimately tunnel the traffic all the way back here to our Kali VM. So to do that, we'll be using the pivot command. So we run help pivot to show us how to use it. So to set it up, we will pivot add, so the type of the pivot, and in this case it's a name pipe, and then the IP address. So this is a really important concept to understand. So the IP address that we're going to put here, 172.16.166.172, this is the IP address of the boss PC, our first initial access VM, right? So let's grab the IP here to verify that this is correct, right? 172.16.66.172. And the reason we're using this IP is that that's the IP address that the victim PC will talk to, because it doesn't have a way to reach all the way to the Kali VM. So it has to use this IP address as sort of the middle point of the tunnel. So that's why we're using that IP address here for the pipe listener. And then the name of the pipe, and in this case, it was configured to BG pipe. And I can show you the commands I use to get the payload there. So for the shell, right, this is just an MS Venom to get the interpreter reverse CCP, pretty straightforward. And for pipe 2, right, so this is the command I use. Oh, so something that is probably interesting here is that for the way SMB works is that you can use different types of strings to sort of identify where you're trying to talk to. So you can use the IP address, and you could also use its net BIOS name. And in this case, I just went ahead and used the net BIOS name. For one of these future podcasts, that'll be really interesting to see if there's a difference if you use one or the other, and in what cases is it where one will work but the other will not work. So just something to keep in mind. So the way that this payload creation works is you have to create the name of the host you're connecting to that's running your name pipe, and also the name of the pipe itself. So in our case, the name is BG pipe. So let's get back here to setting up our listener here, our pivot listener. So we have the name of the pipe, the architecture, which is x86, and then finally the payload, Windows. So we run that, success. Let's list it to make sure it's there. So it tells us it's there. We have an identifier, the URL, which is the IP address, and then the pipe name. So that looks all good. Let's background this. And okay. So one of the things that I should have shown earlier that I sort of forgot here is to run the sysintern tools pipe lists, which will list all of your pipes. So I ran it earlier, so just to show you what it looks like. So this is sort of a good point to sort of explain, what are named pipes. So Microsoft Windows has a set of inter-process communication mechanisms. Some sort of really well-known ones are sockets. There are named pipes. There are mail slots, and there are memory map files. And so what these IPCs are just mechanisms for one process to talk to another process. So, excuse me, when I run this pipe list command, right, it's showing me all of the default pipe lists that are used by various Windows services and processes. So that's what this looks like here, right? So the pipe that we've created with our pivot listener is BG pipes. So we already ran that command, right? So now let's check out what the pipe lists are now. So we run it, and then notice, right? So now the name pipe, BG pipe that we created is now listed. And another interesting information that we should look at is this instant column. So it shows how many connections are sort of how many entities are using that name pipe. In our case, it's just one, our shell.exe process running on this machine. So okay, we have that all set up and it's all nice and good. Okay, so now let's finally go to our final target right here. So our final target right here, right? So I've already, again, right? So I took some shortcuts. So somehow the red team has gotten this name pipe payload onto this particular machine. And now I will execute it, and let's look closely at our calling machine as well when we're executing it, right? So let's run it, pipe 2, execute, boom. So when we ran it, we get an interpreter session callback to our calling box. But notice a difference here that's interesting, right? So it says interpreter session open to, but it also has the string that it was pivoted through 172, which is the boss PC, right? So that's really cool. So, and then another thing we can do to check it out is if we run netsat on our calling box, you notice we only have one established connection, right? So even though we currently have 2 interpreter sessions, one to boss and one to victim, the connection, it's only one connection, the 443 connection. And that 443 connection goes to the boss here. Let's do a netsat here. So that's where it's connected to. But then boss itself also has this connection to the victim PC over 445, which is the SMB port, right? And this is another thing that's really interesting about this particular connection is that normal connections you would see it usually goes over IPv4, and so therefore you'll see an IPv4 address. But in our case, because we're using the SMB name pipe mechanisms, is using an IPv6 address. So that's a really interesting artifact to notice about this particular connection, right? So so let's just play around a little bit with our sessions that came back. So that was session number 2, I believe. Let's validate that with that one. Yes, session number 2. We're here, get UID, and we see, yes, it is indeed victim PC. And the user there is kfan, and we do ifconfig, right? The IP address of that final machine is 173 instead of 172, which is the boss PC. Another thing I wanted to note about this is that, remember when we ran pipe lists, initially we only had one instance for BG pipe, right? So now we run it again, we have 2 instances. So I believe that was what I wanted to show regarding name pipes, SMB name pipes, and its support in metasploit. One thing though, I sort of do want to share is how sort of this use case scenario is very atypical from other use case, how this lateral movement usually works. So what I've seen in other tools such as Cobalt Strike is that what the red team will do is they will actually, after they compromise this first target right here, the boss, then they will use lateral movement to jump to this final machine right here, right? So check this out, right? So we have sysintern tools at pipelist also running on the victim PC, and we were to run it, you'll notice that the BG pipe is not listed here at all. And the reason that is for the metasploit example is because the server that's running the SMB named pipe is actually running here on the boss PC. And therefore, that's why you only see that BG pipe here with the two instances. The example I talked about with Cobalt Strike, where you're sort of from here and then you're doing an SMB connection to the victim PC, and then you create that pipe over here. In that particular case, then you would see that BG pipe listed in this final target VM. But in our scenario, it's different, where the red team somehow got the beacon here and then used it to connect back here. So yeah, I wanted to point that out. And all right, so that concludes the metasploit demo that I wanted to show. The other demo that I wanted to show is a very simple, I wanted to show a very simple client-server implementation of a very basic named pipe application. So the train of thought here is that, I ran a really cool red teaming tool. It was using SMB name pipes. I didn't quite understand how it worked. So then I explored it and got it working with Metasploit and did some research and got a better feel for it, right? So now my next step is like, okay, I want to sort of understand it better. And the way to do that is actually implement some sort of toy implementation of a very simple application that use named pipes. And that's what I end up doing. And the place I got this code was on MSDN. So I just Googled on MSDN for it, and it gave me a very simple client server example of it. And so I'll quickly just go through the code super fast because I'm running short on time here. So this is the server, and sort of the big thing that's happening here is it's creating that name pipe, right? And this right here, name.pipe is going to be the name of the pipe we're using. Okay, so these are the permissions for it, and then it connects to it. And then after it connects to it, it creates a thread. It spawns a thread to sort of handle the interaction for this particular server. So, and the function it will call for it, I believe, is this instant thread, right? And so in this instant thread, it allocates 2 heaps, and then it sort of goes and first it reads from the pipe, and then after it reads the pipe, and then it processes it, what it read, and then it writes to the client that's listening to the pipe. So that's what the server is doing. Let's jump to the client. The client here, so this is a default message that the client's going to send, and also it has to use the right pipe name, a URL, and then also the name of the pipe. And then it creates that pipe. I handle that pipe, and then after it does that, let's see what it does here. Okay, then it reads from it. I'm looking for the right, because I believe it right here. So it writes a message to that pipe, and then it reads to it. So relatively simple. And so now I'm going to run those 2 parts. So this is the server. So I'm going to run the server here. Oh, okay. So this is another thing. So after I ran the server, right? So before, the last entry in our pipe was this BG pipe, but after I ran the server, if I run it, check it out. That name pipe that was created by that server, it's now created with 1 instance. So that's the server. And so now I'm going to run the client. So I'm running the clients. And when I ran the client, if you look back at the server, you see that the server received it, right? And then if we go back to our sysintern tools here, run pipe, notice now there's 2 instances. So this is just a super simple example of a named pipe server and client application. And by going through this process, even though it's not really heavy duty programming, doing this, I get a better feel for how this mechanism actually works. And so when I'm using it for either pen testing or red teaming, when problems happen, right, or when there's something potentially that's unexpected, because I have this experience running this application and troubleshooting the issues, I'm going to have a much easier time of trying to figure out whether what the issue is if I'm trying to use it in a pen testing context. And the other thing, though, I wanted to note, so I showed how to use it in Metasploit and how to run this in this application. So about this application I wrote, I ran it on the same VM. When I tried to run it on two separate VMs, of one for the server, one for the client, it did not work. So according to my simple implementation here, I believe there's potentially problems with having the right permissions. And that was the biggest problem I ran into when I was trying to get my Metasploit example to work, was to set up the permissions, the SMB shares properly for inter-process communication. So one VM can talk remotely to the other VM. And I'll leave that as an exercise for the viewer to, if they're interested, to playing around with this to see, what you have to do to get it working. And with that, this concludes my demo, and I will stop this part, my screen sharing, and let's see if I can do that. Okay.